Hello, and welcome to the SEPjr Cohort 3 webinar. We're going to get started in just a few more minutes, or just a minute or two. Give everybody a chance to log in. Just for your information, if you have any questions or comments, please use the Google Chat section to the right of the screen. You will need to be logged into a Google account in order to ask any questions or make any comments. Also, just to let you know, this will be recorded. So if there's something that you're not sure about, you can revisit this particular webinar. There's also the first two webinars, which the links are available in the application overview. They're pretty much the same thing. It's the same slide deck. I might explain something just a little bit different, but we address the same questions and topics. So. Okay, so I'm going ahead and going to get started because I know it's Monday after spring break and testing starts for many schools tomorrow. So I want to try to provide as much information as possible. So my name is Lionel Bergeron. I'm the Director of Elementary School Computer Science Academics, and I run the SEPjr, or Software Engineering Program, for the Computer Science for All initiative. Just so kind of today's webinar is the application webinar, just to kind of walk through today's agenda and the information that we'll be covering. So first, what is SEPjr and how does it fit into the Computer Science for All initiative here in New York City? A brief overview of the SEPjr curriculum and resources. What are going to be the SEPjr program requirements for not only schools as you're applying, but once you have been and if you are accepted, what those requirements will be. So what the commitment is and the expectations are for participating in SEPjr, and then some application tips, just around how you answer some of the questions and the information that you provide us. At the end, I'll take a look at any questions that you might have. Please place them in the chat box to the right of the screen. Just make sure you're logged into a Google account in order to add those comments in there. So it doesn't look like we have any questions yet. So great, we're going to go ahead and get started. First of all, Computer Science for All in New York City. So Computer Science for All, this is our mission statement. So Computer Science for All will ensure all New York City public school students learn computer science with an emphasis on female, Black, and Latino students. Through our work, students will be better prepared to utilize computer science after graduation. It is part of the Equity and Excellence Initiative. And even though we are part of the Office of Post-Secondary Readiness, we believe that the skill sets that we provide in computer science are valuable even at an early age, kindergarten. And in some cases, we've actually worked with some pre-K students. But what is the Computer Science for All initiative? So the Computer Science for All initiative is, again, a part of the Equity and Excellence initiatives. And the expectation is that by 2025, all students within the New York City public school system will receive meaningful experience with computer science in each grade band, so K2, 3, 5, 6, 8, and high school. SEPjr focuses primarily on K2 and 3, 5, and that meaningful experience is built around a meaningful unit. And the foundation of those meaningful units are right here on this slide. We focus on practice of concepts and from perspectives. And so the three practices that we highlight are analyzing the impacts of computing, prototyping projects connected to interests, and communicating understanding of the concepts. And those concepts around computer science are abstraction, algorithms, programming, data, and networks. And each one of those we approach from a specific perspective as they might relate to the student's age, grade level, or prior experience with computer science. So that first perspective being explorer, which is that opportunity for students just to, again, explore and tinker and play around and just kind of see what computer science is and what you can do with computer science. That moves into the next level of creator. Creator is now taking that knowledge and those things that we learned through tinkering and building something or remixing something, and seeing what we can do with it. The next level is innovator. So now that we have an understanding of what we've explored and we have a better understanding of how we can create something or remix something or make something, now we start to think about how we can come up with something that hasn't been made before, or looking at a specific problem or issue or challenge and developing our own ideas and understanding how those things might have an impact on our school, our community, the world at large. And that leads into the citizen, really understanding how computer science does have an impact on society. And positive and negatives of computer science, and then the how powerful the tool can be, which I think is it's interesting because of what's going on with Facebook recently. This is a really important part of computer science and understanding computer science for students. So these three things: the practices, concepts, and perspectives. Elementary school focuses primarily on explorer and creator, but it's not to say they don't have some experiences related to innovator and citizen. All of these, the concepts, practices, and perspectives, you can find out more about those on the CS for All blueprint. You'll see the link in the bottom right-hand corner, blueprint.cs, the number 4all.nyc. And the blueprint is a digital resource for schools and teachers. It helps define that meaningful CS learning experience as an exploration of concepts and practices with depth of knowledge. It equips teachers with sample CS units as we build those out. It showcases pedagogical practices from computer science teachers, i.e. Project-based learning, universal design for learning, cultural relevance. We also, talk about different pedagogical approaches for computer science, collaboration through pair programming, those types of things. It also provides implementation support for teachers and administrators. So giving them an idea of, the best way to implement and integrate this computer science into their schools. Elementary school, I know that programming or scheduling is a really important part, or content integration. And then finally, the blueprint was developed through a co-design process with teachers, administrators, CS Ed community, industry, and academics. Because we believe that the more involvement of teachers and those in the school community, as well as the computer science education community and computer science in general, makes it a more valuable tool, and it makes it more practical for the schools and teachers that are using it. When you visit the website, you'll see your landing page brings you to a selection of 3 videos. I highly recommend watching the elementary school video all the way to the left there. There's a couple of SEPjr schools that are highlighted, the ones working on game controllers and then the ones working on circuits. Paper circuits, and this video will inform you, especially towards one particular question from the application. So make sure you do, when you have a chance, watch that video. Now, it's also important to recognize, especially on the elementary school level, that computer science, it's more than just the skill set that we're trying to teach our students. Computer science is an educational imperative, but it's also an economic and equity. We believe that the academic end of it provides students with a skill set that's going to help them in the future, but also trying to make computer science available and accessible to all students, whether that's through unplugged activities, online platforms, mixed between the two, robotics, computational media. We believe that all students should be exposed to computer science. So again, CS for All Expectations 2025, that each student will be provided at least one unit of computer science, every student in K2, 3, 5, 6, 8, and 9, 12. One of our ways of reaching that particular goal is through our PD options. You also see pictures throughout this whole presentation. These are all SEPjr teachers and students. So kind of, if you have a chance to focus on those for a moment, it kind of gives you an idea of what your experience would be. But we kind of start off with an intro, 1 day of training, which is really to build and start thinking about what computer science implementation your school might look at. Often these are around Computer Science Education Week. Some of you might have already attended one of the co.org CS Fundamentals PDs, those 1 day trainings that just kind of gives you that first touch, light touch on what computer science is. Then the next level of training through the CS Institute will provide a more comprehensive PD for teachers that are implementing that meaningful unit. Next is the courses. These are primarily middle school and high school, which allow for scheduling a specific period for computer science, often as an elective. In high school, we have even the AP computer science course. And then finally, we have what's called the sequence, which is up to 100 hours of training per year to implement a full sequence of computer science. And that's what SEPjr is. It's a sequence. And the goal is that through professional development, schools will begin to implement computer science throughout the school year, not only during those grade bands, but every single year a student is at the school. So SEPjr, the expectation is starting in kindergarten, first, second, third, fourth, fifth grade. Every year they're receiving that one meaningful experience, and really more than just that one meaningful unit. And the content curriculum around SEPjr is kind of built to provide that resource for teachers to implement and schools to implement that. So I touched a little bit upon it right there. So what are the goals of the software engineering program as one of those sequences? So the first is increase the number of elementary students, particularly from traditionally underrepresented groups who learn computer science. That's from our mission statement as a Computer Science for All initiative. It helps develop students' computational thinking and problem solving skills in real world context. And so that has to do with that underlying skill set that we're looking to develop within our elementary school students, that even though if they choose not to become computer scientists or work in the computer science field, they're still benefiting from the experience of being exposed to computer science at an early age. And then finally, it enables students to engage in computer science instruction in each year of elementary school. So again, that's kindergarten through fifth grade. So they should have up to 6 experiences, a minimum, throughout their time at your school. And that expectation, of course, is not within the first year. We expect schools to, within 2 to 4 years of participating in the SEPjr program, to make that happen. So the SEPjr curriculum is designed to provide all students in the school with a deep exposure to computer science concepts and practices as identified in the blueprint, through a sequence of computer science experiences that build on each other from year to year, thus offering a really truly rich elementary school computer science experience that kind of exceeds that initial goal of that single unit, meaningful experience. If you're familiar with co.org, an example, co.org now has a courses A to F. So A is kindergarten, F is fifth grade. And so each year the students do one of the courses within co.org. It's the same idea. So each year students will be working towards student outcomes based on those perspectives, and using different types of platforms and resources, i.e. maybe co.org, but the FOOs, Scratch, project-based learning, physical computing, to really get a meaningful experience throughout their entire time at your school. We really look to fuse computer science into the school's vision. One of the ways, some of the ways that we do that are one, through effective leadership. So really helping teachers and schools develop a vision and implementation guide for how computer science will look at their school over that course of like how will it look, their first year SEPjr, their second, third, and the expectation by the fourth year having that meaningful experience for all students at each grade level. Helping set those goals, like, those benchmarks, like what do we want first, second, third, and, how do we meet that goal? Knowledge that they can turnkey. So teachers attending PD, of course, we can't train all teachers within a SEPjr school, but that core group that's attending professional development, providing them the resources so that they can go back and teach the schools, the other teachers in their school, the content, so they can themselves start implementing computer science. And that relates to the scalability, like working with the school on, well, how do we get there? Do we focus on, one unit across K to 5, or do we focus on like the first year K and third grade, and then the next year increase it to first and fourth, and then the final year would be third and fifth, depending on what works for your school. We help build out that plan. Rigorous instruction, again, you saw the blueprint. We're trying to infuse those practices and concepts into all of our content, and then also through professional development and professional leadership, really making sure that we're providing the resources needed to learn and understand computer science and computational thinking, and then the units within the sequence course. So when you're learning computer science, we have 5 course like content areas or focuses, which is Introduction to Computer Science, Fundamentals of Computer Science, Robots, Physical Computing, and then project-based learning. And we have modular units that are available within each of those content areas and that, address specific student outcomes. And throughout the K to 5 experience for students, the school decides like which units best meet those student needs to reach those student outcomes. We also believe in strong family and community ties. So helping develop resources for teachers during parent-teacher conferences to help relay that information on like what the students are learning and what's the value of computer science and computational thinking in the classroom. Computer Science Education Week, which is in December, it's a big celebration around computer science and like really informing the community around us. We also have 2 additional events that SEPjr schools participating in. One is Maker Week, typically in May. That's an opportunity for like the physical, like creating something, designing, building, that design, engineering design process. And then finally, School Showcase at the end of the year, where students and teachers have an opportunity to really share what they've learned and what they've achieved in those wonderful artifacts that come out of computer science. Just a fun little thing, if you're curious on what professional development for the CS for All office looks like, or what the classrooms might look like, I definitely recommend searching the hashtag CSFOR ALLNYC, either on Facebook, Twitter, or Instagram, on any of those social media platforms, and you'll get an idea of like what you might experience during participating with Computer Science for All. So instructional support. This is a picture of one of our PD sessions for SEPjr. They're learning the mouse robot, and so we're going to talk a little bit about that. So instructional support. So ongoing instructional support for the school year. So as Cohort 3, professional development for all teachers, which per session is provided. That starts off in June 9th. We have our Cohort 3 kickoff. That's an opportunity to kind of explore those concepts, practices, and perspectives and give the schools and teachers an idea of like what those are, but also an opportunity to kind of for those teacher teams to get to know other schools and really start to set goals for themselves for the school year and what they would like to see happening in their schools around computer science and SEPjr. Then in August 6th to the 10th, there's 5 days of mandatory summer, the Mandatory Summer Institute. This is 5 days of professional development where we really start to dive into the content related to elementary school. We do look at some specific platforms, but we really want teachers to, have a really strong come out of that week with a strong understanding of the concepts and practices, how they're going to be teaching those to their students throughout the school year, and then looking at the tools used to teach those concepts and practices. There's a diverse a number of resources available to teachers in elementary school in computer science, and a lot of them, are really wonderful tools. But the focus is on those concepts and practices, and they're almost tool agnostic. So that way, it gives schools the flexibility on implementing the SEPjr program. So more specifically around the curriculum and materials, teacher-directed and project-based curriculum with unit plans and activities. So we try to provide all the resources necessary for teachers to be successful, between teacher-directed lessons, but also project-based curriculum. We really want students and, based on that prototyping idea, to really build something, create something, and make something that they themselves can then look at, evaluate, and iterate on, and really understand how they're applying those computer science concepts. The activities are always fun. They're unplugged online, they're physical, they get students moving around. We also try to incorporate universal design for learning. So we're trying to make the activities as accessible to all learners as possible, but then we also support teachers in differentiation. As I mentioned before, the curriculum topics include, but are not limited to, the introduction of computer science, fundamentals of computer science, robots, creative computing, and physical computing. Now, this is really important. We do robots. We don't necessarily do robotics, so there isn't a lot of build. We use the dash and dot, or the mouse robot that you saw in that PD picture, where students are learning more about the programming of robots, but also robots offer an opportunity to understand sensors, inputs, outputs, data, things like that. We align the curriculum with the Computer Science for All blueprint. So I've mentioned it a few times. You'll see that there's student outcomes. Those student outcomes are based on the concepts, practices, and perspectives. And those are really, for now, they're really what we're trying to teach our students, and how students will be assessed. There are other standards out there that can be useful for teachers, such as the CSTA and the ISTE standards, but they haven't been adopted by the state or city. So for right now, we are very focused on Computer Science for All blueprint and those student outcomes, because those we feel are the best way to gauge and to set goals for our students' understanding. And then the PLCs, we have optional participation in a computer science professional learning community for all teachers who have been trained via online, like online discussion groups such as Slack or Google Hangout. We also are trying to develop some online content and courses, or just connecting teachers with those resources. For example, Google has a really great computational thinking course. Also, Discovery Education has something called Ignite My Future, which just provides additional support and understanding for teachers as they build their capacity to teach computer science. So we have webinars and also partner workshops. So, it's really important for us to distinguish between computer science and computer literacy, or instructional technology. You may be using Google Classroom in your school, or like Chromebooks, and that's great, and those are wonderful resources. Google Classroom isn't necessarily computer science, it's more computer literacy, or using Google Forms or Google Docs or Google Sheets, and using Google Slides. Those are really important skill sets, but that's more digital literacy than it is computer science. And we also help schools to kind of like connect with those additional professional developments related to those types of things. Also, is another thing is digital citizenship. These might be built into some of the activities and projects we do in computer science, but computer science is focused more on like how a computer works rather than just using a computer. Yep. So what are the program requirements? Excuse me. So our first and foremost expectation for SEPjr or schools participating in SEPjr providing ongoing instruction of the software engineering program or SEPjr curriculum throughout the year at each grade level. So again, starting in kindergarten, and then first, second, third, fourth, and fifth grade, students are receiving computer science at one point throughout the school year. And the expectation is that they'll receive multiple ones. And we believe that as teachers develop their capacity to teach computer science, they'll find ways to integrate multiple units throughout the school year, each school year. And we expect schools to plan towards ensuring SEPjr participation by all students within 2 to 4 years. So, at the earliest, by the second year, all students are getting some computer science each school year, but within 4 years, meeting that goal. So how to staff for SEPjr? So the first thing is that core group of teachers that will be attending this year's professional development. So provide at least 5 licensed teachers. This will include a teacher team of 2 at each grade band. So 2 teachers in K to 2, 2 teachers in 3 to 5, and then 1 coverage or cluster teacher to attend the professional development sessions. So that core group would attend the June PD and then the August one. And then we also have 1 PD every Saturday throughout the school year, which I'll talk about in just a second. So that's what we're really looking for. We are inviting schools to create teams up to 7. So if you have 3 teachers in each grade band and a coverage teacher, that's great. If you have the coverage teacher is typically the computer lab teacher or the technology teacher. Some schools also, in addition, have a STEM teacher. So you could have that combination of adding in a STEM teacher as well as a computer lab or technology teacher. And it's not to say that the coverage teacher has to be either of those 2. We've had librarians, we've had art teachers, science teachers. It's just that one teacher in a position to meet with multiple classes throughout the school year in computer science. That coverage teacher also kind of teams up with the classroom teachers implementing SEPjr to kind of help balance out the content, because we do understand that classroom teachers are expected to teach other content areas, and in some cases up to 4, and that integration sometimes needs a little assistance with the coverage teacher. Please note, schools are encouraged to provide, again, up to 7, possibly 1 at each grade level. So a kindergarten, first, second, third, fourth, fifth, and that technology teacher or coverage teacher. We're also looking for to dedicate an administrator as a point of contact for the program. This administrator is really encouraged to attend a lot of the professional development, so they themselves has an understanding of what computer science computational thinking is about and what the expectations of the SEPjr program is. This helps with planning, scheduling, helping the teacher team set aside time to meet as a team. And then this also helps with planning for scaling after that first year. How do you start getting computer science to the other teachers in the school? They also help with administrative issues such as, shipping out materials and resources and receiving those types of things. Again, the goal of reaching student outcomes, SEPjr schools will be provided with curriculum and professional development materials to reach the student outcomes related to those 2 perspectives of explorer and creator. Again, you can find all those student outcomes on the CS for All blueprint or blueprint.cs4all.nyc. And then SEPjr teachers are expected to attend all mandatory professional development PD sessions. If you look in the application overview, it provides you the tentative dates for all of our PDs, the June PD, the summer PDs, and the Saturdays, which is one Saturday a month. We're looking this year to expect all cohort 3 teachers to attend 5 of the PDs, and then 4 of them will be more grade specific or content specific. So under some circumstances, some teachers might not attend one of those 4-day PDs, or one of those 4 Saturday PDs, because it might not be applicable to what they're implementing in their school. But we still are expecting definitely mandatory for June, August, and at least 5 of the 9 PDs throughout the school year. It will be mandatory for all schools to have participating teachers. It just depends on which teachers from the teacher team they're applicable to. So committing to providing SEPjr to all students. So again, SEPjr is designed for schools that are committed to planning towards ensuring all students, not just select group students engaging in CS experience, made possible through the SEPjr curriculum. This is that equity element of it. Like, we really want all students within a SEPjr program to receive computer science, not just the select group or that one teacher that's really engaged with computer science. We're trying to design a way where not only are the students empowered with computer science, but all the teachers in the school are empowered to teach computer science. So each SEPjr school should reach full implementation of the program within 2 to 4 years, at which point 1 or more units of CS instruction is being provided to all students at each grade level. All new students entering grade K will receive 1 or more units of CS introduction each year. So that's the idea. Once they come in at kindergarten, each year they receive at least 1, hopefully more, units of computer science. And the curriculum is designed to support the flexibility for schools in regards to which and how many units are taught in each grade level. And the idea behind that is that we understand that kindergartners might not be able to get through 3 units. So we make the units available where, a new teacher to computer science in kindergarten might choose 1 meaningful unit in the intro to computer science for that first year. But then as those students progress and develop their capacity, the expectation is that we really want to challenge the students to learn more, so that by 5th grade, they have the potential of maybe shifting from block-based programming to text-based programming. Or, if they haven't received physical computing in their first few years, they're receiving it in their upper elementary grade levels. We really want to challenge schools, but it's also built around those, availability of resources. Let's say you don't have tablets available for every grade level. So we make sure that the modular units provide flexibility on what platforms being used, how many unplugged versus online activities are being used. And we really work with schools to kind of develop that plan of their own. Again, it is very important to understand that computer science is very different than computer literacy. Word processing, a very valuable tool, typing, a very valuable tool, and we try to support those things, but that is not computer science. 3D programming isn't necessarily computer science. It does have elements of computational thinking and design process, but we really want schools to, focus on the computer science concepts and practices. So to continue that, SEPjr schools are not expected to initially offer CS to every student or at every grade level, as outlined in the previous bullet, but are expected to acknowledge this expectation up front. We really want schools that are applying to this to understand that this is our goal for you and our expectation for you to participate in that full implementation of computer science within 2 to 4 years. And again, a commitment means designating and supporting a team of teachers to serve as the CS team for their school, who would help with strengthening the culture around computer science teaching and learning in the school, and also recruiting and supporting any additional teachers who are necessary to provide SEPjr to all students. It is important that when you're filling out your application to inform those teachers that they are being put on this teacher team, because based on the application that we review, we make selections based on, part of it is based on that teacher team. And if you are accepted and then change that teacher team, that can affect your participation in SEPjr moving forward. So, sometimes we have circumstances that teacher team that shows up in June might not be the exact same teacher team that shows up in August, based on teachers moving or shifting of grade levels, which we understand. But we really want to make sure that initial application teacher team reflects the teacher team that gets started in September. Too much shifting and it's hard for those new teachers coming in to catch up, or the team gets unbalanced where there's too many early elementary and not enough upper elementary. So we really take that into account, and it can affect your participation in SEPjr. So finally, how to support the goals. Again, increase the number of elementary school students, particularly from traditionally underrepresented, who learn computer science. Develop students computer science. I feel like we've done this one. Well, just it's important to revisit them. So again, we expect the schools to support the goals of SEPjr, and again, increase the number of elementary school students, particularly from traditionally underrepresented groups who learn computer science. Develop students' computational thinking and problem-solving skills in real-world contexts. And enable students to engage in computer science instruction each year of elementary school. Again, I know I've said it multiple times, but it's important to say it again so there's an understand. Because this is in a sequence, the expectation is that they're receiving it, throughout the school year. And even though there is a sequence, the curriculum is designed around the idea that, I know when I was in my school, I would have 1 year, all my 6th grade students came from our 5th grade class. But then the next year, half of my 6th grade students were from other schools or outside New York City. So we do have that understanding that you might get a 4th grade class or a 5th grade class that has had no computer science experience prior to coming into your classroom or one of your SEPjr classrooms. And we really try to build out the curriculum so that we help those 4th and 5th graders still leave that elementary school with a really solid foundation of computer science. Now, of course, it might not be, they might not transition from block to text-based programming, but they really have an understanding of those concepts and practices that we've mentioned. So selection criteria and application tips. What are the SEPjr current program requirements? So in order to qualify for SEPjr program, you must currently offer a meaningful computer science unit to all students, once in kindergarten through 2nd grade band and once in 3rd to 5th grade band, or at least have a plan to do so by the end of the 2018-2019 school year. So what this really means, just to kind of break it down, is that we really want schools that already have thought about how they can start bringing computer science to their schools. If your school has had no computer science experience, your teachers have had no computer science experience, SEPjr isn't the best starting point for them because it is such an intensive program. The CS Institute might be something more applicable to them, and then later on applying to SEPjr. But we want schools that have an understanding of, like, maybe you have a group of teachers that have implemented the CS fundamentals content from co.org. And we really ask that in the application, you demonstrate this. Like, there's a question about, like, what's your current computer science education plan? This is also an important place to differentiate between computer literacy, instructional technology, digital citizenship. Those 3 things are very different than computer science. You should be addressing things like how you're talking about either the concepts or practices, especially around algorithms, programming, data and networks, those types of things. What are your thought processes as a school, and what are your plans and expectations? If you were not to get into SEPjr next year, what would you be doing around computer science? How would you be meeting those goals? So again, we're looking for schools to participate in SEPjr that have either implemented, are looking to implement, or plan to implement some computer science, at least on the grade band levels. If you're not familiar with the Meaningful Unit is, you can find more information on the Blueprint website, but just kind of a brief overview outline of it. A Meaningful Computer Science Unit provides students with 10 to 25 hours of computer science education in the following areas. So like in all three of those following CS practices of analyzing, prototyping, and communicating. So your expectation already is that students will be analyzing elements of computer science, building something with it, and then being able to discuss or communicate how they build something. And should be addressing at least three of the following CS concepts. So again, as I mentioned before, they're talking about abstraction, algorithm, programming, data, and networks. Like, what are your current plans for addressing at least three of those five concepts? Have you addressed that? Have you started teaching students elements of algorithms and programming through Scratch? Have you done some abstraction elements through unplugged activities related to the Hello Ruby books? Things like that. Please make sure you can articulate a plan that will ensure that teachers in one or more multiple grades in both the K2 and 3-5 grade bands are ensuring that every student in the school is receiving a meaningful CS unit. So we really want schools to look at the content that's on the blueprint, think about their school culture and their school structure, and really provide an outline or understanding or a description that helps us understand what your plan is for implementing computer science on the K2 and 3-5 and meaningful units. Also, selected schools will be required to deploy, maintain, and sustain technology and academic infrastructure that ensures students receive adequate access to the SEPjr related resources. This is that one of the questions asks, how do you support technology in your school? Do you designate the computer lab teacher as also the IT person that helps fix and update computers? It's important to recognize that there is a plan in place and that one person isn't bearing the responsibility of all those things. Like, do you have a mouse squad? Maybe part of your computer literacy program in your school or digital citizenship is that you have students supporting teachers or other students, like an upper grade supporting a lower grade. We really want to know how you maintain and sustain all of your technology within your school. Do you work with DIIT? Do you use Google Classroom? Those types of things. And then finally, leadership and support. Instructional and administrative support is paramount for the success of the SEPjr program. So this is very important that the support's already in place in your school through administrators or through your school-based coaches are participating in some form or another in the computer science SEPjr program, and that and also finally the SEPjr is a 2 to 3 year program requiring the commitment of administrators and teachers in each grade level. So this has more to do with the long term. So that initial team will participate in the June, summer, and Saturday PDs. But then the second and third year, we'll be inviting schools back in previous cohorts to participate in additional professional development to kind of build on what their understanding is. So like if your school is kind of elected to bring in a lot of content around Scratch Junior and Scratch, some of your teachers who have participated in the past or some of your new cohort teachers within the school might attend a Saturday PD that focuses primarily on Scratch Junior and Scratch and project-based learning. So that's the idea around that 2 to 3 year program requirement, because we really want to support teachers through at least 3 years to reach that goal of implementing by year 4. Schools should have a clear implementation plan for integrating the SEPjr curriculum into into the daily curricula and schedule for grades K-5. We really would like schools to demonstrate and explain how they expect teachers to teach computer science, whether it's in content integration, team teaching, things like that. It's also important to understand that SEPjr is not a club. It's not an after-school program. So we are not looking to work with schools that, for now, if that's your goal, that's great. But that's an initial implementation. We really want the SEPjr content to be part of the daily curriculum. And it's also important to understand that, eighth period on Fridays is not going to reach the goals that we set for SEPjr. And then selected schools will be required to clearly identify what practices are in place to support the expansion of computer science throughout the school year. And we really want teachers and schools to explain how they currently provide professional development in-house. Have you implemented a program or initiative in your school, and like how did you scale it out so that all teachers are participating in that particular initiative? And then finally, schools should be able to articulate their initial plans and thinking for how they will ensure that after 2 to 4 years, all students entering the school will receive at least 1 unit of computer science at each grade level. So what is your plan? Start thinking about it now in your application. Kind of give you an explanation of like what that core teaching group is going to look like, and then how would you expand it out? Is it going to be focusing on one meaningful unit that can be taught throughout the 5 years, like choosing 1 unit per grade? Or are you going to focus on, grade bands first? Like I said before, kindergarten and 3rd grade, 1st and 4th, 2nd and 5th. Like, really want you to demonstrate your initial plans and your expectations for reaching that 4-year goal of 1 meaningful unit of computer science at all grade levels. So finally, just some tips, what we're looking for. We definitely want in your application to demonstrate that you reviewed the blueprint. You need to look at the blueprint. There's also video within the blueprint that we ask you to look and reflect on. Again, that's blueprint.csforall.nyc. We really want a clear understanding, you to demonstrate a clear understanding of what computer science education is, and again, as it relates to those concepts and practices and how it differs from computer literacy, instructional technology. We are thoughtful answers to application questions. This is our only way of understanding what you're doing in your school. One sentence answers, are really not going to provide a clear understanding of what your school is about and the work that you're doing. So be meaningful in your answers, and also if you have links to online student artifacts of the work that you've done already, that's great. That definitely helps us. Anecdotal content is really useful. We, as the Computer Science for All initiative, understand that computer science is very important. You do not need to reiterate that to us, that, we understand that, in 2020, there's going to be 1 million unfilled jobs because of a lack of computer science education. Like, we understand those key parts, but really get down to the granular, like, give us a view of like what your expectation as a school is. Also include a strong teacher team. Again, we're looking for several schools who provide at least a lead teacher for each grade level, K to 5, plus a tech teacher when available or where available. And then also make sure that it's you help use the application to demonstrate the support of the administrator and who will be providing that support to that particular teacher team. Just a couple of dates. Again, we've gone through the application timeline. It opened up, application was released on March 20th. We had a couple of the webinars. The applications will close on April 20th at 5 p.m. So please make sure you have your application completed. You are able to revisit your application. So if you've got it started, that's great. But you must make sure that you have completed it by end of business day, April 20th. So that's 5 p.m. Final decisions will be sent out on May 18th. That first professional development is June 9th. Again, the August PD is August 6th through the 10th. And then you can look on the overview guide for more information about the tentative Saturday dates. So any questions that you might have, I'm going to click over to the YouTube screen, and it doesn't look like there's any questions. Just give a quick few minutes for any questions. I know I tend to talk pretty fast. There's a lot of content to go over. As I said before, this is recorded, so you can go back and revisit this. All right, well, it seems like there aren't any questions, so I'd like to thank you for attending. Again, you can, if after looking through this, and you realize that you did have some questions that you didn't have a chance to ask, you can email us at programs@strongschools.nyc, and we'll try to respond as quickly as possible. Also, again, the application overview provides a lot of this information as well as the blueprint. Okay, thank you very much for attending.